Hello, we move on with more theorems on lines and angles. I think a couple of 3 or 4 of them were left. Where once we discussed the few in the last session, the ones which were left, I draw a couple of figures first and then explain. The theorem reads, if the two parallel lines are intersected by a transversal. So the two parallel lines which is said is AB and CD. It is intersected by a transversal, suppose L. It says the bisectors of any pair of alternate angles. I take this to be one pair and I bisect that. I also take the one which is equal to that one will be this. Now if we are drawing the bisectors of the alternate angles, which I have assumed to be this and this, and then maybe I name them as M, N, this is suppose A, B, C, D, E, F. Then M, E and F, N will also be parallel. The same will be applied when we draw parallel lines and transversal and the bisectors of corresponding angles. I keep the same name as I did for the previous one. This is E, this point of intersection is F. We'll be drawing the bisectors of corresponding angles. I'm taking this and this. If I draw the bisectors, that means this again I name M and this to be N. E, N will also be parallel to F, N. That means if the two parallel lines are intersected by a transversal, then the bisectors of their corresponding angles will also be parallel. Now I draw the third one, or I can simply read out to you the theorem and take the same figure. If it is given that this line, this is parallel to the line the bisector line of the corresponding angles, there is a transversal, then the lines A, B is parallel to CD. One more with I think I am leaving is when there are two parallel lines, a line which is perpendicular to one parallel line will also be perpendicular to the other parallel line. So I read and make this figure like, suppose AB is given parallel to CD. The transversal L, so ABCD, this is E, F. L is perpendicular to AB at the point E. That will also make L parallel to CD at the point F. We are now done with the theorems. We take up few questions based on these parallel lines and the theorems. I think 7 to 8 theorems we have discussed. I take the first question and draw the figure for it. Oh, sorry. I better draw straight line. This is A, B, C, D, E, F. The question says AB is parallel to CD, CD is parallel to EF. This is denoted as Z, this to be Y and this to be X. It says Y is to Z is equal to 3:7 and we have to find the value of X. Now if we observe, x and z are alternate angles, because if AB is parallel to CD, CD parallel to EF, that also makes AB parallel to EF. Now if AB is parallel to EF, we have read it in a theorem previously, so x is equal to z, x is equal to z. In that case, if I am expressing y and z in terms of the constant k, so it is 3k is to 7k, I can easily substitute x as z, that is 7k. Now y plus x is 180 because they are interior angles on the same side of transversal. You can write here, they are pair of interior angles on the same side of transversal. Ignore any spell mistake if any. Okay, y will then be substituted as 3k, x can be substituted as equal to z, given to be 7k, and that's equal to 180. So it's 10k equals 180. So k is 18. K is 18. X we had assumed to be 7k. So it will be 7 into 18. That makes, I think, 126 degrees. Move on with more question. Okay. I take a couple of minutes every time to draw this figure. This is L, then M, and then N. This point of intersection X, that's Y, and this is Z. In the figure it says L, M and N are parallel lines intersected by the transversal, which is named as P, at the points X, Y, Z respectively. Find the value of, suppose 1, this is 2, and Z, this is 3. It is given in the figure that this angle is 50 degrees. For our usage, I'll name maybe this as angle 4. Now, angle 4 plus 50 degree will make 180 degrees. So, angle 4 is 130 degrees. Now, angle 4 and angle 2 make corresponding angles. These two. They make corresponding angles because L and N are parallel lines. So, angle 2 will be 130 degrees. Angle 2 is equal to angle 3 being vertically opposite. That makes angle 3 as well 130. What about angle 1? Now, angle 1 is equal to angle 3. If you observe, this is equal to this because they are alternate interiors. As M and N are parallel, so 1 is also 130 degrees. Let's take up another question. I draw the figure. They are not accurate figures. It is A, it is B, this is named as C and D, the names which have been used. This is E, this is F, this is G. Now the question reads as AB is parallel to CD. EF is perpendicular to CD, so that means we need to mark it here. Angle GED is given to be 126 degrees. GED makes this angle. So we have to find angle AGE. We have to find angle GEF and angle FGE. AGE is this angle, which is alternate to angle GED. So angle AGE is equal to angle GED because they are alternate angles. So angle GAGE will be equal to 126 degrees. Now we have to calculate GEF is this portion only, GEF. If you look carefully, angle GEF is equal to angle GED minus angle FED. So GED was 126 minus FED is given to be 90, so that makes it 36 degrees. Last one is FGE, this. Now angle FGE plus angle AGE equals 180 degree because they make a linear pair. So angle AGE was 126 degrees, so angle FGE will be 180 minus angle AGE, that's 126. They're making it 54. Rather, I'll leave the next question for you to solve by yourself. I draw the figure. Let me take a minute to draw the figure. I write whatever are the names. This is A. This is supposed to be B, that's C. This is D. This is Y. X, R. There are few points of intersection, so now the question reads, AB is parallel to CD. Angle APQ is 50 degrees. Angle PRD is given to be 127 degrees. You have to find the values for X and Y. I'm sure you'll get them correct because it's not difficult at all. They are very simple application of the theorems which we have discussed in a few sessions. Thank you.